Now that you have designed for high availability using regions, availability zones, and failover patterns, you are ready to design for a tougher reality. Some events exceed what high availability can handle. High availability reduces the chance of downtime during common failures. But disaster recovery is about restoring critical services after major disruption, including region-level incidents, widespread cyber events, and operational failures that require a controlled rebuild. Your goal as an architect is to make sure the business can survive the worst day, not just the average day. With that context set, you need to define disaster recovery in leadership terms so the organization treats it as a business capability. Disaster recovery is the plan, design, and operational readiness to restore services and data after a major disruption within agreed time and data loss limits. Leaders care because disasters are not only technical failures, they are business disruptions with financial, legal, reputational, and safety consequences. When you design disaster recovery properly, you are not promising perfection. You are promising preparedness, predictability, and controlled recovery under pressure. With disaster recovery defined, you now clarify the difference so expectations do not get confused. High availability is about staying available during many types of failures through redundancy and rapid failover. Disaster recovery is about restoring when parts of the system are unavailable or corrupted and you need an organized recovery process. A system can be highly available but still not recoverable if data is corrupted, if backups are unusable, or if dependencies are not included in the recovery plan. Leaders value this clarity because it prevents false confidence. Architects value it because it keeps design scope realistic and complete. With the difference clear, you now start where disaster recovery must start: business impact analysis. You do not begin with technology. You begin by identifying which services are critical, what the cost of downtime is, what legal or regulatory obligations apply, and what operational consequences occur if the service is unavailable. This is where leaders and architects align on priorities. If you skip business impact analysis, you either overinvest in low-value systems or underprotect systems that keep the business running. With business priorities defined, you now explain recovery time objective in a way leaders can use for decisions. Recovery time objective is the maximum acceptable time for a service to be restored after a disruption. It is not a wish. It is a commitment that drives architecture design, operational readiness, and budget. A recovery time objective of minutes implies a very different design than a recovery time objective of hours or days. When you make recovery time objective explicit, you turn resilience discussions from vague fear into clear engineering and governance choices. With recovery time objective understood, you now define recovery point objective in business terms. Recovery point objective is the maximum acceptable amount of data loss, measured in time, that the business can tolerate after a disruption. If the recovery point objective is 5 minutes, you must replicate or protect data with very frequent recovery points. If the recovery point objective is 24 hours, backups may be sufficient for many systems. Leaders care because data loss has direct financial and customer impact. Architects care because recovery point objective drives data architecture, replication choices, and the complexity of recovery workflows. With both objectives clear, you now establish a governance model for workload classes. You group workloads into tiers based on business criticality, and each tier has standard recovery time objective and recovery point objective expectations. This prevents every project from negotiating recovery targets from scratch and prevents leaders from being surprised later by inconsistent resilience outcomes. It also creates a consistent funding model because higher resilience tiers require higher investment. When you standardize tiers, You create predictable decision making and reduce political debates during design reviews. With workload tiers established, you now identify the disaster scenarios that shape your design. You plan for region disruption, large scale platform outages, ransomware and destructive cyber incidents, accidental deletion and misconfiguration, insider threats, and third party dependency failures. The reason you name scenarios is not to create fear. It is to ensure your design covers realistic threats that can remove availability or corrupt data. Leaders value scenario-based planning because it demonstrates preparedness. Architects value it because each scenario drives specific design requirements, especially around data integrity and recovery workflow. With scenarios in mind, you now introduce disaster recovery patterns as investment choices. A pilot light approach keeps minimal components running in the recovery region, ready to scale during recovery, which can reduce costs but may increase recovery time objective. A warm standby approach keeps more capacity running, reducing recovery time objective but increasing cost. An active-active approach runs across regions continuously, improving resilience and reducing recovery time objective but increasing complexity and operational discipline requirements. Your role is to align the pattern to business impact analysis, recovery objectives, and organizational maturity rather than picking the most complex option by default. With patterns defined, you now focus on the heart of disaster recovery: data protection. Disaster recovery fails most often because data is not recoverable, not because compute cannot be redeployed. Your strategy includes backups, replication where required, and protection against tampering through immutability where appropriate. You also define retention and recovery validation expectations so backups are not treated as a checkbox. Leaders care because data loss can be worse than downtime. Architects care because data protection choices directly affect application design, cost, and recovery workflow complexity. With data protection addressed, you now add a modern requirement: cyber recovery. In many incidents, the challenge is not only restoring service, it is restoring trust in data and systems. If attackers have modified data, stolen credentials, or embedded persistence, restoring from the wrong recovery point can reintroduce compromise. Your disaster recovery strategy must include clear criteria for clean recovery points, separation of recovery environments where necessary, and operational controls that prevent rushed restoration from becoming repeated compromise. Leaders care because cyber recovery protects reputation and compliance. Architects care because cyber recovery requires stronger governance and disciplined recovery processes. With cyber recovery in mind, you now focus on dependency mapping because disaster recovery is never about one component. Your service depends on identity systems, network connectivity, domain name resolution, encryption keys, monitoring, and external providers. If you recover the application but forget identity integration or key management, you have not recovered the service. Your disaster recovery plan must map the full dependency chain and include recovery sequencing. Leaders value this because it avoids surprise failures during crises. Architects value it because it reveals the true scope and prevents incomplete recovery designs. With dependencies mapped, you now clarify that disaster recovery is not complete when you fail over. You also need failback, meaning the plan to return to normal operations when the primary region or primary environment is stable again. Failback often has risk because it involves data reconciliation, controlled cutover, and careful change management. If you do not plan failback, you can turn a short disaster recovery event into a prolonged operating problem. Leaders care because prolonged operating instability increases cost and risk. Architects care because failback requires disciplined sequencing and clear governance. With the life cycle understood, You now focus on disaster recovery testing because untested plans are not plans, they are documents. Testing proves whether your recovery time objective and recovery point objective are achievable. It exposes gaps in runbooks, permissions, dependencies, and data recovery. It also trains teams to operate under pressure, which reduces mistakes during real incidents. Leaders care because testing reduces business risk and improves audit readiness. Architects care because testing reveals design weaknesses that can be fixed before the next crisis forces emergency recovery. With testing positioned as essential, you now show how to make it practical. Effective drills are planned, scoped, and aligned to business tolerance. You define what is being tested, what success looks like, who participates, how evidence is captured, and what improvements will be made after the drill. You also ensure the drill test real recovery steps rather than only theoretical checklists. This approach keeps disaster recovery testing from becoming either too risky to run or too shallow to matter. Leaders value this because it makes preparedness sustainable. Architects value it because it provides measurable feedback loops. With drills made practical, you now define governance because disaster recovery is cross-functional by nature. You clarify who owns disaster recovery policy, who owns technical implementation, who owns application readiness, and who owns operational execution during events. You also define who signs off on recovery time, objective and recovery point objective commitments, and who approves exceptions. Without governance, disaster recovery becomes a shared responsibility that nobody truly owns. With governance, it becomes a managed capability that improves over time. With governance defined, you now anchor disaster recovery in a realistic scenario that leaders recognize immediately. Imagine ransomware encrypts key systems and compromises administrator credentials. You cannot simply fail over and continue because you may bring compromise with you. You must decide the clean recovery point, restore data safely, verify identity integrity, and re-enable services in a controlled order. If your recovery time objective and recovery point objective were never agreed, leaders will demand impossible outcomes during the crisis. If they were agreed and tested, you can execute a disciplined recovery that balances speed with safety. This is why disaster recovery is a leadership decision that must be made before the incident, not during it. Let's now discuss the key takeaways from what you learned so far, so you can design disaster recovery in Azure with clarity and confidence. Disaster recovery is a business capability that restores services and data after major disruption, and it is distinct from high availability, which focuses on staying available during common failures. Recovery time objective defines the maximum acceptable downtime, and recovery point objective defines the maximum acceptable data loss, and both must be agreed through business impact analysis, not guessed by technical teams. Workload tiering creates standard recovery expectations and prevents inconsistent resilience outcomes. Disaster recovery patterns such as pilot light, warm standby, and active-active represent different trade-offs between cost, complexity, and recovery speed. Data protection is the heart of disaster recovery, and modern designs must also address cyber recovery where data integrity cannot be assumed. Dependency mapping ensures you recover the full service, not only the application, and planning for failback prevents prolonged instability after recovery. Disaster recovery testing turns confidence into evidence, and effective drills require clear scope, measurable success criteria, and continuous improvement. Strong governance defines who owns commitments, who executes during events, and who drives improvements over time. If you want your organization to be prepared for the worst day instead of hoping it never happens, subscribe so you can continue through the rest of this playlist and build the full enterprise Azure architecture step by step. Like this video, so more leaders and architects learn how to design recovery with clarity. Comment with your biggest disaster recovery challenge, such as defining recovery time objective, defining recovery point objective, or running meaningful tests, and share this with your team so you can align on recovery commitments and build a disaster recovery program that the business can truly trust.